Hello and welcome to this MEI M1 revision video where we're going to be looking at force as a vector and at Newton's laws. This is June 2011 question 3. So this is the full question. We're given three forces F, G and H, and part 1 of the question tells us that F and G act in parallel lines and we've got to find Y and Z, which are these two components of the vector G. For part 2, we are told that F and G are the only forces acting on a mass of 5 kilograms, and we have to find the acceleration of the object and also the magnitude of the acceleration. So that's 2 marks and 5 marks for those two parts of the question. So let's have a look at part 1. We're told that F and G act in parallel lines. So F is -2, 3, -4. G is -6, Y, Z. And we need to say, right, well, if these two are parallel, they will be a multiple of each other. And so looking at that X component, I can see that F has to be multiplied by 3 to get G. We could say G is 3 times F. And so working out the other two components, 3 multiplied by 3 is 9 for Y, and -4 multiplied by 3 gives us -12 for Z, so that's 2 marks. Then moving on to part 2, F and H are the only forces acting on this object. So F, just to remind you, is -2, 3, -4, and H is 3, -5, -1. We're going to be using F equals MA. So what we need to do for the F is find the resultant force, and the resultant force is what you get when you add these two together. So resultant force F is equal to the mass, which is 5, multiplied by the acceleration. So working out that left hand side, we're going to get 1 -2 -5 is equal to 5a. And so dividing by 5, we could write it like this for the acceleration, or if you wanted to, you could write it as a vector with decimals. So 0.2, -0.4, and -1 if you prefer. Now that's the actual acceleration, that's a vector. We also have to work out the magnitude of the acceleration. I'm going to work from this line here. I'm leaving the 5th outside. And the magnitude of that vector is 1 squared plus -2 squared plus -5 squared. So underneath the square root there we get 25, add 4, add 1, so that's root 30. And you can leave it like that if you want to as a third, or if you work it out as a decimal, it's 1.095. So that would be 1.10 if we were working that out to 3SF. So that's the magnitude of the acceleration. What we'll do now is we'll go back to the beginning of the question and we'll have a look at how the marks are allocated. So for the first part, 2 marks, we get 1 mark for indicating that we're scaling this up by a factor of 3, and you have to get both of these two correct to get the second mark, the accuracy mark. Moving on to part 2, you get an independent mark for showing this resultant vector of F and H. We get a method mark for applying F equals MA in vector form. And we get an accuracy mark for getting the correct acceleration. So that's 3 marks, and then the other 2 are for finding the magnitude. So there's 1 mark for showing a correct method to find the magnitude, and then a follow-through mark here for this final answer. So as long as you follow through from your acceleration vector, you would get this correct even if you'd made a mistake over here with the acceleration. If you'd like to look at any other revision videos, go to our website www.furthermaths.org.uk.